Hello students, myself Ashish Chawla, and today we start the chapter Polynomial. Now, before starting the chapter Polynomial, we have to understand the various terms. The first, we understand the term that is algebraic expression. Now, what is algebraic expression? Algebraic expression is basically an expression containing constants, variables, and the basic arithmetic operation. Algebraic expression is an expression which contain constant, variables, and basic arithmetic operation. Basic arithmetic operation. तो उसे हम algebraic expression कहेंगे. For example, 3x square minus 5y plus 8. It is an algebraic expression because it contains the constants. The constants are 3 is a constant, 5 is a constant, and 8 is a constant. 3, 5, and 8 are constants. Where here the constants are 3, 5, 8 are the constants, and the variables here x and y, these are the variables. X comma y are the variables, and the basic arithmetic operations. Basic arithmetic operation means plus, minus, multiplication, division, etc. Mathematical operation or arithmetic operations. Arithmetic operation means plus, minus, multiplication, and division. These are the basic mathematics. Here there is a minus sign between these two terms, and there is a plus sign between these two terms. So these are the mathematical operations, that is minus and plus. And 5 and y, there is no sign between them, so it means they are multiplied. So there is a multiplication sign between 5 and y. Same way 3 and x square, there is no sign between 3 and x square, so it means they are multiplied. So there is a multiplication sign by default. So in this way we can define an algebraic expression, that is an expression which contain constant, variable, and basic arithmetic operations is called an algebraic expression. Here there are various terms in this algebraic expressions. The terms in this algebraic expressions are 3x square is a separate term, 5y is a separate term, and 8 is a separate terms. There are three terms, that is 3x square is a term, minus 5y is a term, and 8 is a term. So these are the three terms in this expressions. Now after that, now we are defining what is a polynomial. A polynomial is basically an algebraic expression in which the power of the variable must be a whole number. What is a polynomial? Polynomial is an algebraic expression in which power of the variable must be a whole number. It means the power of the variables must be positive or maybe 0, but never be negative or not be in fraction. So it means power is not negative as well as not in fraction. For example, let's say 3x square minus 5x plus 7. Is it an polynomial? Let's check the power of the variable first. So here x, the power of the variable x is 2, that is an whole number. Here the power of x is 1, it is again a whole number. So we can say that it is a polynomial. Now let's take another example. Is it a polynomial? Let's check the powers of the variables first. So here x, the power of x is 2, so it is a whole number, correct? Now here the power of x is 1 by 2. So 1 by 2 is nothing but a fraction. Root x can be written as x raised to the power 1 by 2. So this is an fraction. This is a fraction. So that's why it is not a polynomial. Let's take one more example. Is it a polynomial? Here only we have to concentrate on the powers of the x, not the constants. So here we don't consider root 3 because it is a constant. We have to see the powers of the variables only. So here the power of the variable is 2, here the power of the variable is 1, so it is satisfy our condition, so it is a polynomial. Let's take one more example. X square plus 5x plus 6 divided by, let's say, x. So is it a polynomial or not? Let's divide x square by x. We are getting simply x. 5x divided by x. We are getting 5. Now when 6 is divided by x, the 6 is x is shifted to upward side and become minus in power. So this expression become like this. That is x plus 5 plus 6 x raised to the power minus 1. So here the power of the variable is negative. So that's why it is not a polynomial. Let's take one more example. X cube plus 7x square plus 2x divided by x. Now from these three terms there is x is common in all the terms. So we take x common. So the equation become x square 7x and 2 only, because we are taking the x common from all these three terms, so it becomes like this divided by x. Now this x and this x are get cancelled, so we getting x square plus 7x plus 2. So again we check the powers of the variables. Now here the power of the variable is 2, that is whole number. Here x, the power of the variable is 1, so it is a whole number, so we can say that it is a polynomial. Now after that we can classify the polynomials according to the number of terms. So we discuss now the classification of polynomial according to number of terms. So the first classification, that is monomial. As the name suggests, mono means single. If a polynomial contains only single term, only one term, then it is called a monomial. Example 7x. It is a polynomial because it contains only one terms. Or let's say x, y, z. It is a polynomial, or you can say it is a monomial which contains three variables x, y, and z, because it is only the single term, that is x, y, z. So it is a monomial. Now the next classification, that is binomial. As the name suggests, that is bi means two. So a polynomial contain two terms, we say it a binomial. For example, x plus y, because these are the two terms, x and the y. Let's say another example, x square minus 7. It is also a binomial because it contains two terms. One term is x square, another term is 7. So now the third classification, that is a trinomial. What is a trinomial? As the name suggests, that is tri. Tri means three. A polynomial contains three terms is called trinomial. For example, x plus y plus z is a trinomial, or you can say x square minus 5x plus 6 is also a trinomial because it contains three terms. Now, if an polynomial contain more than three terms, we simply call it multimonial or simply polynomial. Multimonial or simply polynomial. More than three terms, we simply call it multimonial or polynomial. For example, w plus x plus y plus z. So these are the four terms: w, x, y and z. These are the four terms. Or example, let's say x cube plus 5x square minus 7x plus 2. So it is again containing the four terms, so it is a multimonial. More than three terms means multimonial. Now after that, we define the degree of the polynomial. What do you mean by the degree of a polynomial? Now we define the degree of a polynomial. What is the degree of a polynomial? Now, when a polynomial is only in one variable, if a polynomial contain only one variable, let's say x, then the highest power of variable that is x is called the degree of that polynomial. For example, let's say x raised to the power 5 plus x cube minus 7x square plus 8x plus 9. So this is a polynomial which contains x as a variable. Only a single variable is used, that is x. So the highest power of that variable, that is x, is called the degree. So here the highest power of the variable is 5. There are various power of x, that is 5, 3, 2 and 1. So among these, the 5 is the highest one. So we can say the degree of this polynomial is 5. Let's take another example. Minus 7x plus 5x cube plus 8x square plus 9x. So again we are seeing the powers of x. So here the power of x is 1, here the power of x is 3, here the power of x is 2 and x is 1. Among these, 3 is the highest power of the variable. So the degree of this polynomial is 3. Now what happened if a polynomial contain more than one variable? Let's say if a polynomial contain more than one variable, more than one variable, in that case, in that case, in that case, the degree of the polynomial is the highest power obtained by adding the power of the variable in the term, For example, let's say 7x square plus x cube plus 8x square y square plus 9xy. So if someone asks you what is the degree of this polynomial, so what we see here, in this polynomial there are two variables, so that is x and y. We can say that this polynomial in two variables. Now to find the degree, so here the maximum power x is 2, here 3, the power of x is 2, here the power of x is 3. Now, when we are seeing this term, that is 8x square y square, this term contain two variables, that is x and y, and we have to add these two powers, that is 2 plus 2, that is 4. So here the power of the exponent is, power of the variable is 4 now. Here the power of the variable is, the power of the x is 1 and the power of y is 1. So when we are adding these two powers, that is 1 plus 1, we are getting 2. So among these 2, 3, and here it is 4, and here it is 2 power. So among these three powers, the highest power is 4. So we can say that the degree is 4, because we have to add these powers of the variables, that is x is 2, y is 2. 2 plus 2, that is 4. Let's take one more example. X, y, z plus 7x square. Now, what is the degree of this polynomial? Now, here in this term, what we seeing that it contains three variables x, y, and z, and their powers are 1, 1, and 1. When we are adding these three powers, 1 plus 1 plus 1, that is 3. We are getting 3. And here the power is 2. So among these two, 3 and 2, the 3 is the greatest. So the degree is 3. So in this way, we can define the degree of the polynomial. We can classify the polynomials according to the degree as well. So we see the classification of the polynomial according to degree. Now the first classification is constant polynomial. What do you mean by constant polynomial? Constant polynomial is the one whose degree is 0. उसे हम constant polynomial बोलेंगे जिसकी डिग्री क्या हो 0 हो. For example, 7. 7 is a constant polynomial. Why? Because here the power of the variable is 0. 7 can be written as 7 into x raised to the power 0. So it is nothing but 7 can be written as 7 into x raised to the power 0. X raised to the 0, we know that it is 1. So 7 into 1 is 7 again. So here the power of the variable is 0. Here the power of the variable is 0. So we can say that all the constants having degree 0. What is the degree of 3? Again 3 into x raised to the power 0, that is 0. All the constant having degree 0. For example, what is the degree of 2 raised to the 3? It is not 3, because 2 raised to the 3 can be written as 8, and 8 can be written as 8 into x raised to the power 0. So we can say the degree of 2 raised to the power 3 is 0. Now after that, the next classification, that is linear. So when a polynomial having degree 1, then it is called a linear polynomial. For example, simply x plus 7. So here the highest power of the variable, that is x, is 1. So we can say it is a linear polynomial. Simply x can be written as, now the third one, quadratic polynomial. In quadratic polynomial, the degree of the polynomial is 2. The degree of the polynomial is 2. For example, x square plus 5x plus 6. So here the highest power of the variable is 2. So it is a quadratic polynomial, or simply xy we can say, where the power of x is 1, y is 1. So it is a single term. So 1 plus 1, that is 2. So here the degree is 2. Now after quadratic, cubic. So when the degree of the polynomial is 3, we call that it is a cubic polynomial. For example, x cube plus y, or you can say x, y, z. So it is a single term which contains three variables x, y, and z, and we have to add all these variables powers. 1 plus 1 plus 1, that is 3. After cubic, we have biquadratic. Biquadratic. In biquadratic, the degree of the polynomial is 4. So it is called a biquadratic polynomial. For example, x raised to the power 4 plus 1. or you can say x square y square, or you can say x cubed y. So these are the examples of biquadratic which is having degree 4. Here x square y square 2 plus 2 we get 4. Here x cube y 3 plus 1 we getting 4. It is simply x raised to the 4, that is 4. So these are the classification of the polynomial according to degree. Now after that we define what are the like terms and the unlike terms. Now, like terms and unlike terms are defined as if the term containing same variables with same power, then the term is said to be like terms, then the terms are said to be like terms, otherwise they are called unlike terms. Terms containing same variable with same power are called like term, otherwise they called unlike terms. Example: 3x square y comma 5x square y. So these are the like terms. Why? Because these are containing the same variables, that is x and y, x and y. Here the power of x is 2, here the power of x is also 2. Here the power of y is 1, here the power of y is also 1. So these are the like terms. Let's take one other example: 5xyz, and let's say 6x square yz. So in these two terms the variables are same, that is xyz. Here is also xyz, but here the power of x is 1 and here the power of x is 2. The power are different, although the y and z are having the same powers, but the power of x is same. So we say that these are the unlike terms. These are not like terms, these are the unlike terms. Why? Because the power of x is different. So in this way we can define the like terms and unlike terms. So what is the use of like terms and unlike terms? We have a concept that only we can add the like terms. We can add only the like terms and we can subtract the like terms only. But we cannot add and subtract the unlike terms. We can add only the like terms. We cannot add the unlike terms. For example, if I have to add 3x plus 5x, so 3x and 5x, these are the like terms. Why? Because these are having same variable, that is x and x. So and their powers are also same. So these are the like terms and we can add them. So here the coefficient of x is 3. Here the coefficient of x is 5. So 3 plus 5, that is 8. We have to add the coefficients and we have to write the variable as it is, x. So we can add only the like terms. 3x and 5x both are the like terms, so we can add them. So 3x plus 5x becomes 8x. For example, if someone asks you add 3x square plus 5x, so we cannot add. Why? Because here the variables are same, that is x, but the powers are different. Here the power of x is 2, here the power of x is 1. So these are the unlike terms. So we cannot add the unlike terms. So it becomes as it is, that is 3x square plus 5x. We cannot do nothing in this. So kept as it is, that is 3x square plus 5x. So we can add and subtract only the like terms.